Vivekanand, am I audible to you?
Yes, sir. You're audible.
Okay. Okay, let me check the sound. The sound is coming properly or the voice was low?
No, sir. It's coming properly.
Okay,
It's proper.
it's good now. So, as I put in the post, you can see here that we are going to discuss about SQL Server and query performance tuning and optimization. This is the 9th batch. Actually, I started this batch, this training in last year, so far I remember, from March or April I started, right? So till now I have covered eight batches, and this will be the 9th batch. Okay. So for this, I have selected 2 topics for the demonstration. So demonstration topics include 2 things. Today we will go with course overview. First, I would like to discuss what we are going to cover under this course of SQL Server query and performance tuning. And the main topic that we will discuss today is performance killers, right? This is the agenda for today. And the next day agenda uh, is covered troubleshooting high CPU utilization issue. By mistake, it is written here. It's a type of unitization. It should be read as utilization. So troubleshooting high CPU utilization issue. It's a day-to-day issue that DBAs are facing especially, right? So many people have confusion that whether this course is targeted for administrators or developers. This course is targeted for all developers, administrators, and database architect as well, right? So in my earlier batches, many of the database architect were there who attended this course. So performance tuning, we will cover from all prospect, from administration prospect to development prospect, right? From all prospect, we will cover. And since it's a day-to-day issue that people are facing, right? I have included here. So there are very advanced concepts behind that. We will discuss about those things tomorrow, starting from SQL OS. We'll discuss the max degree of parallelism, cost threshold for parallelism, how these two are interrelated, what are the different weights, which statistics you should look for, and how you can calculate those statistics against these 3 weights, right? Thread pool, SOS scheduler yield, and CX packet to determine whether your SQL server is suffering from high CPU utilization from SQL point of view or not, right? So these are the things that we will discuss tomorrow. It's a big topic, and at least it will consume 2 hours, right? Maybe it will consume more than 2 hours. This is also a big topic, performance killers. Once you understand about the performance killers, you have a solid base of performance tuning, right? So let us have an course overview first, and after that, we will start to discuss about performance killers, right? So this SQL Server Query Performance Tuning and Optimization course will be based on SQL Server 2017. And when we talk about performance tuning, uh, we talk performance tuning and optimization from 3 dimensions, from 3 prospects, from 3 aspects. First is your SQL Server configuration and database level setting, that is SQL Server configuration setting on server level and database level settings. So what are the important server level configurations you have? For example, You have server level configuration as max stop. You have server level configuration as mean memory and max memory. You have server level configuration as affinity masking. You have server level configuration as fill factor, right? There are uh, enable or disable ad hoc query parameter, optimize for ad hoc workload, that is enable or disable for optimization of ad hoc workloads. These are the different server level settings, what they mean and what should be their optimum value that comes under server level configuration that we will discuss. There is one dimension of performance tuning. Another dimension is database level setting, right? That what are the different parameters you have on database level, starting from the layout, how you lay out your database, what should be your storage selection, right? How you should host your database, how you should divide your database into multiple secondary file, why under multiple file groups, right? Then why you should enable auto growth, why you should not enable auto growth. If you enable it, what should be the auto growth value, right? That we will discuss. So different concepts are there under database level settings that we will discuss. Guys, give me a second. So what are the different things you have available on database level settings that we will discuss. Then we will discuss on query level how you can tune the queries. So query tuning is an art, you know. Configuring SQL server level setting and database level setting is, uh, you know, the core task of administrators. And uh, tuning queries are although core task of developers, but nowadays a trend has developed that demands query level tuning from administrators as well, right? Guys, I'm putting you all on mute. Some background noise is there. If you can unmute, if you can mute yourself, that's fine. Otherwise, I will mute you all. I can see Francis has joined. Hello, Francis. Can you hear me?
Yes, I can hear you.
Oh, okay, good. That's fine. So, what I was talking, this is the important point you all have to note. There is a demand now that uh, companies are looking for performance tuning from query level tuning from administrators, DBAs as well now, right? Earlier, it was not the core responsibility of DBAs, but nowadays this trend has developed. So if you attend any interview, I'm sure that people will ask you many questions, at least, you know, one third question from the performance tuning itself, right? Let me tell you one more fact, that there was a misconception spread all around, you know, DBAs and developers who are working on SQL Server when Azure was developed. When Azure was developed and introduced, I'm talking about SQL Azure single database and managed SQL database. There is one concept that is known as automated tuning, right? So many of the people think that this automated tuning is going to tune the queries itself, right? this is a misconception, right? It only suggests you uh, missing indexes. Hello, am I audible?
Yes, sir. Now audible.
Okay, I was lost for some time, right?
Yes, sir.
Okay. So due to automated tuning, there was a misconception around the people that there is no need to learn performance tuning. There is no need to do performance tuning on server level or on query level, right? That is a wrong concept. It only suggests you missing indexes, nothing more than that, right? Query level tuning is a vast thing. We will go ahead when we will discuss many things under query level tuning. It's a broad part, right, of query level tuning. This is one aspect of the performance tuning, right? So you cannot ignore any of the aspect of the tuning that you see on the screen here. Tuning from SQL Server, SQL Server settings, that is configuration settings, or you can say SQL Server level parameter settings, tuning from database level settings, tuning from database design, right? I will put some focus on database design also, right? And tuning on query level. So under performance tuning, database design matters. If your database is poorly designed, right, although you have configured your SQL Server parameter settings properly, you have done good settings or optimum settings for your database settings. You have written a wonderful query that is completely optimized, right? But still you get slow response of the queries, right, due to your poor database designing. So what are the different factors that makes the database design poor that we will discuss under this database design aspect, right? So these are four aspects you can say, or dimensions of performance tuning. You have to learn around this, and I'm sure that many of you know many of the things. So the question is here that how much you know and what you understand from that and how you are going to implement, right? That is important. I have seen many of the people that if I ask a question that if you face high CPU utilization, what are the different stats what are the different weights you are going to analyze whether the SQL Server is suffering from high CPU pressure or not. So simply I get the answer most of the times as CX packet, SOS scheduler yield, and thread pool are the major three weights that we will look for. Then if I ask the question what you will look for in those weights, I didn't get any answer, right? So the DMV that you use, that is DM underscore OS weighted stats, provide you multi-column information. So I will show you tomorrow about those things. There are some columns which has its own meaning, like uh, total waiting time that is reported under wait time in MS column. Then you have signal wait time. So what is the meaning of signal wait time? You have to understand. Then there is a concept that is called uh, max wait time, right? So what this column information mean and how you can interpret the stats that you have gathered using that DMV against these uh, three weights, right? So we will explore those all things, how to analyze that, and then how we can uh, you know uh, judge that whether SQL Server is suffering from memory pressure or not, because sorry, CPU pressure or not, because The DMOS weight stats will certainly provide you uh, information about these three, most of the times, these three weights that I told you: trade pool, SOS Schiller yield, and CX packet. So if they appear in the output of DMOS stats DMV, it doesn't mean that my SQL server is suffering from CPU pressure. Rather, we have to analyze the stats against the weights, right? So how we can analyze that, we will discuss. So these are the different aspects of performance tuning that we will every topic that we will discuss under performance tuning will be related from these four aspects of performance tuning, right? Then the topic of today is performance killers in SQL Server, right? So say your SQL Server is suffering from performance issue, right? And you have to determine that what is the exact reason of the performance issue that my SQL Server is suffering from, right? So for that, you must have good knowledge of killers, right? That what are the different kinds of killers those exist in SQL Server. You have to analyze those killers. So the important point here to note is you first must have good knowledge of killers. That what are the different killers that exist in SQL Server, and then you have to think around those killers. So for example, if anybody is suffering from fever and he goes to the doctor, so doctor first analyzes that with what kind of infection he's suffering from, right? Whether it is a viral infection, whether it is bacterial or something else, right? So once the cause is determined, the killer is identified, right? Then uh, doctor, doctor has diagnosed that killer, that bacteria or virus, that is the reason of your disease, right? And after that, he suggests some medicine to take, right? Or go for some test, and after that, test some medicine. So the same thing is here. When your SQL Server is suffering from performance issues, you have to diagnose it for the killers that may exist in SQL Server, right? And once that killer is identified, here comes your knowledge in the picture using which you remediate that problem, right? The remedy is the knowledge. Using it, you try to eliminate or remove that killer, right? So this is just a glimpse of the major killers that exist in SQL Server. The first one is poor indexing. We will talk about this today, right? This is also known as missing indexes, poor indexing or missing indexes, we can say, right? Second is inaccurate statistics. So even though you have written a very good query that is completely optimized, you have proper indexes as well, but your statistics is outdated. It becomes stale or inaccurate in that case. The estimation of the rows on which a particular operator has to work in the plan, I will tell you what I'm saying you. Today we will discuss. Uh, that will be not accurate, right? So stale statistics or outdated statistics provides you inaccurate statistics about the data for which an operation has to be performed by an operator, right? And ultimately, it results in poor estimation of the number of rows on which a particular operation has to be performed by a particular operator, right? So it slows down your query response, or it slows down the query performance. Poorly designed query is, of course, a major factor of your uh, slowness of the query, right? So, how we can write a good query, and what are the major factors that make the query, uh, poor by the design that we will discuss. It's a big topic. Then one of the major performance killer is bad parameter sniffing, right? So for that, you have to understand what a parameter is, what parameter sniffing is, and when a parameter sniffing becomes bad, right? Many of the times I have seen this issue with the stored procedures or with the dynamic SQL, which are executed with some input parameter values, right? At that time, you may experience bad parameter sniffing cases, right? So when you are executing a query, which is part of a stored procedure, and for every execution of that stored procedure, if you pass different parameter values, right? So your query executes with different parameter values each of the time. Uh, that may lead to bad parameter sniffing case. That is not for sure, but may lead. And most of the times I have observed that stored procedures which are executed with input parameter values are mainly victimized by the bad parameter sniffing case. So this is one of the major performance killer. Excessive blocking and deadlocking is also a major performance killer. So blocking and deadlocking, these two are the natural phenomena that exist in any multi-user system. It's not only true with the relational database management systems such as SQL Server, Oracle, or DB2, but it is true for any multi-user system as well, right? A blocking or a deadlock situation. Am I audible, guys?
Yep.
So what I was talking, that blocking and deadlocking is a natural phenomena that that exists in any relational database management system, but excessive blocking and deadlocking ultimately degrades the performance of SQL Server, right? So this is one of the major killer. Then there is only non-set-based operation that exists in SQL Server under the T-SQL, that is cursor, right? So SQL Server understand a language that is known as T-SQL. This was developed by Microsoft. It stands for Transact SQL, and all the operations that you perform, select, right, or when you do, so in select, you do sometimes projection, you do sometimes selection, you do sometimes intersection, you do sometimes joins, union, right? These all are set based operations. They all operate on a set of data. Your table is a set of data, right? And even the 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 uh, the result set that you get is also a set of data, right? So all statements operates on a set of data. Only cursor is there in SQL Server uh, that uses a concept that is known as row egonoing, which means that it performs row by row operation, right? Not it does not perform operations, read or write operations on a set of data at a time. It performs uh, read or write operation row by row. So that concept is known as row egonoing, right? What what permission you want, Ravi? Ravi Kumar, what permission you want?
Recording.
No, recording I am doing. I cannot allow anyone to record. I am doing it,
Fine, fine. It's
right? I will share after the class.
okay, fine, thank you.
Don't worry, guys. So one thing should be clear to all of you that uh, after each of the class, not only this demo class, you will be I will share recording with all of you, whosoever will get admission in this course, right? And then whatever the documents I will use for the training, that also I will share. So I want to just show you what I'm doing. Uh,
So yeah, Neeraj, so we can access these videos for lifetime, right? So there is
no,
no
no,
expirations, right?
no. There is no facility like lifetime. What I will do, I will give you the link. From there, you
Okay,
can access. You can
okay,
download it. You can put it in your laptop or any device by yourself. You can
okay,
learn.
okay.
Yeah,
So once we can download, we can use for lifetime, right?
yeah. I am not running. Yeah. You download, and now how you are using that, it depends on you. How
Yeah, yeah.
safely you are
Okay.
you are keeping that, right?
Yeah, sure.
So I just want to show you that I have been sharing all the recordings. You can see this is the performance tuning class 14 recording. You can see here. Mm, just a minute. You see here. Please download class recording by tomorrow, Yuri. This is meeting recording link that was shared for class 14 and class 12 recordings, right? If you come down, you will see class 15 here. This is for DBA batch. Uh, where is that? Class 14, class 13 recording. No. Many of the recordings you will see here, 12 and 13. So after the class, right, on the same day or next day, I usually, provide the link from where you can download the recordings. Okay. So
Hi
let's
Neeraj,
see.
Rakesh joined.
Hi, Rakesh.
So is that demo over or still in the way?
No, we have just started.
I'm little bit late, so I think it was still at 7. So
No,
I
no,
was
no.
just downloading Zoom and it takes time. Yeah.
Demo is go long. It's scheduled for 7 to 9, but it can even last up to 9:30. No problem. You know.
Okay.
So what I was talking about this, right? So all are clear that documents will be shared, right? And recordings after each class will be shared. There is no problem at all. You asked me just, Mahesh. You came late here. We have just started the demo. Even we have not yet started to talk on. Uh,
Oh,
I
okay,
will
that's
have
fine.
to put you all on mute then. Some background noise is there. Guys, try to put yourself on the mute and unmute yourself only when you have to speak, right? So that will not cause any trouble for me or you as well. If there will be some background noise, then the recording quality will be poor. I don't want to put you all on the mute so that you should be able to speak. That's why I'm not putting you all on mute. Okay, so what I was talking that recordings after each class will be shared with you along with the document that will be used in the training. That is the first thing, right? And second thing, we were talking about the topics. Okay. Poor database design basically refers to few things, right? That uh, if your database does not meet 3NF rules, right? Then your database, you can say, is poorly designed. If you don't have proper indexes, right, cluster index and non-clustered index, then your database is not properly designed. If you have unnecessary introduced many triggers, your database is not properly designed. If you are Just a minute, guys. Sorry, guys. I will take one more minute. No, this demo, still we have not entered into the topic that is supposed to discuss, right? So it will go long, at least for next 1.5 hours it will go, right? I will take a minute and then I will resume. Okay, guys. So if anyone is having any sound problem, right? I request you to disconnect and join again, right? Because if the sound problem is there from my side, then it will be for everyone. Okay. What you are saying, Chandra? No. You can unmute yourself. I have allowed you to unmute, right? So rather than typing, you can speak. I will not have to, go from here to there. You are allowed to speak. Okay, so the next, Vivekanand, am I audible to you?
Yes, sir. Audible.
Okay. Okay. The next major performance killer is excessive fragmentation.
Now voice is breaking, sir.
This fragmentation refers to fragmentation on index level, right? So whenever you create an index, that is created with the help of multiple index pages. I don't want to go in internal things right now. We will discuss about the indexes structure in the class. That is usually consist of your indexes internally are uh, made up of B trees, actually made up of B plus trees, not of B trees. So we will see also the difference between B trees and B plus tree. Anyway, your your indexes consist of multiple index pages, and the fill factor that you specify while you are creating an index that decides the fullness of the page on the index for the index. So by default, the fill factor is 100, right? 100%. It means that your index pages are completely filled with the data. That is a big topic of discussion also, right? What should be the optimum value for the fill factor? So again, it depends upon the nature of the data, nature of the table, whether it is read only or data in the table is static in nature, or the data in the table is transactional in nature, right? So when we talk about OLTP environment in which we work most of the times, so in OLTP environment, the tables that you create are highly transacted, right? So there, the fill factor value, the best considered fill factor value is 70. I will show you in, I will demonstrate these things in the classes, that how specifying fill factor value as 70% can help you in reducing fragmentation on index pages or fragmentation in the index, right? I will show you. So excessive fragmentation more than 30% is considered as, considered as a bad thing from performance point of view. That's why it is suggested that you must rebuild or reorganize your indexes at least on weekly basis, right? So that is one of the measure of factor. Then you have non-reusable execution plans, right? So reusable execution plans are considered only in two cases. The first is the plan which is generated against a stored procedure. A stored procedure is called a once compiled object. So once it is compiled and its plan is generated, that plan is used over and again for the subsequent execution of the stored procedure, right? And the second case is when you execute parameterized query, then also its plan is not generated over and again, right? But whatever ad hoc queries you have that you execute, right? Every time you execute an ad hoc query, its plan is generated. So those becomes your non-usable plan, right? So reusable plans also impact the performance of SQL Server, because each time a query and an ad hoc query you are executing, or any user or users are executing, right? Its plan, their plan or its plan has to be generated, and plan generation is a CPU intensive task. That's why it slows down the performance. Frequent recompilation of queries. This is one of the major cause of performance degradation of your queries in SQL Server, and this happens due to high pressure observed in the memory by the lazy writer. So lazy writer task is also to flush unused plans, and also there is one factor that is known as aging. So on the basis of aging values, lazy writer flushes plan from the plan cache. So if plan is not there for a query which was executed earlier, and lazy writer has flushed that plan from the plan cache, then again that query has to be recompiled, its plan has to be generated, right? So it's problematic. So frequent recompilation of queries are one of the major performance killer as well. Okay, then improper use of cursors. So here you see one of the major cursor is non-set based operation. Your cursor is a non-set based operation. And here I have written improper use of cursors, right? What does it mean? Cursor is a non-set-based operation that follows a concept of row egonoing, where it reads each and every row one by one, right? It's very similar to our DO object that we were using in Visual Basic, right? So it reads each and every row of the table or the set that you specify for it, right? The data set that you specify for it. So cursors are fine to be used against your views or tables that exist under sys schema. For example, if you are doing, suppose if you are doing some, automation task where you have to use tables or views under sys schema, right? You are fine to go. You are fine to go as an administrator, you are, or a developer. If you want to automate something from SQL Server administration point of view, that is fine, because your views or tables under sys schema contains not more than 1,000, 2,000, or 4,000 or 5,000 rows. But if you use cursors against a large set of data, I mean that a table consists of more than 5 lakhs, 10 lakhs rows, right, or more than 1 million rows. In that case, you will see that it will degrade your performance. So that's why I written here, one of the major killer is improper use of cursors. Improper configuration of database log file. So it simply says that your log file must reside on a different disk drive than the data file, right? Or the backup file that you have hosted. So we will have a discussion on this also. Improper use or improper configuration of tempdb, right? It's a big topic. So what are the different objects that usage or tempdb? What are the different objects that do not uses tempdb? It's a big topic of discussion. Likewise, a question may be asked in the interview that in what scenarios tempdb is used, right? So most of the people answer that the temporary tables, the temporary variables that we create uses tempdb space, right? But apart from that, there are many factors which compel the use of tempdbs, such as if you perform any order by operation in your query, right? If you order by means ascending or descending, it's a sort operation. So that sorting is done in tempdb. When you create or rebuild an index and you select an option that sort result in tempdb, in that case, tempdb is also used, right? When you use table variable, there is a misconception among people that table variable does not consume memory, right? Uh, sorry, table variable does not use tempdb. That is wrong conception. Table variable also uses tempdb. The only difference is that between temporary table and table variable is that on table variable, you cannot create indexes and stats, right? But table variable is again also created in tempdb on disk, right? When we talk about improper configuration of tempdb, it simply says that if you have not created your data files as per the number of logical procedures that you have assigned to SQL Server, say for example, this is my SQL Server. I have 4 procedures on this system. I have assigned all procedures to SQL Server, right? So if I have 4 procedures, I should have created 4 data files, right, for the tempdb database, right? If I have not created 4 4 data files, right, then my tempdb is not configured properly. You can see I have created 4, right? One is default one, and then after that the 3 secondary file. One is your mdf, and then you have 3 secondary data files here. So 4. If I have 4 logical processors, I should create 4 data files again with equal initial size and with equal auto growth. If I have 8, I will go with 8. If I have 16, still I will go with 8 only. 8 is the boundary. You should not go beyond that. But if you have multiple processors, say for example 32 processors, you can go beyond 8. You can go up to 12 or 16, but you should not go beyond 8. That should be your practice, right? But if that is the demand, right, you can go. If you see that there is a contention issue in TempDB for writing data on TempDB or reading data on TempDB, you can increase the number of data files, right? But the standard practice is you should not go beyond 8. But if you have only four processors, you cannot go with 8. You can go only with 4. If you have 8, you can go up to 8 secondary data. I mean that 8 data files. If you have 16, still you go with 8. If you have 32 processors, still you go with 8. But in case of 16 processors or 32 processors or 64 processors, you can go beyond 8. But for the initial configuration, you should go with 8. Later you can increase, and always increase it by 4 data files, right? So for example, from 8 to 12, from 12 to 16, in this manner you have to go, right? So these are the major performance killers that we have observed, right? So any questions so far you have?
Yeah, Neeraj, Rakesh here. Sorry to interrupt you.
Yeah, tell me.
So, like as you stated, even we have a 64 processor,
Mm-hmm.
and then initial configuration we have to create 8 data files. Is it
Yes,
correct, right?
yes, that is correct.
So when we have to consider for 12 and 16?
If you see that your TempDB is experiencing contention still, right? There are contention issue on TempDB, then you should increase it by 4. First try 8 to 12. You should not directly go to 16. Then observe that whether the contention issue has been resolved or not. If it still exists, then increase it to again by 4, 16, but not go beyond 16.
Okay, so second question, that how we can check, like let's suppose we have configured today only, right?
Mm-hmm.
So how we can ensure that there is no contention on database? So how we can check?
You will have to work on that. So that we will discuss under troubleshooting TempDB. I am coming to that topic. That is not the agenda. It's a big topic.
Okay, fine.
Last, you can see a troubleshooting TempDB performance, right? This is your troubleshooting IO performance and troubleshooting memory performance. Troubleshooting CPU pressure also should be there somewhere. So these are the topics that we will cover. Troubleshooting CPU, memory, IO, performance issues, right?
Okay, got it. Thank you.
So under the,
Neeraj, I have one question, Avinash here.
yeah, Avinash, tell me.
In your setup, I have seen that that initial size should be same, right? Like 8 MB, 8 MB for all the data files.
This is just for demonstration, but initial size, you should put enough initial size to your data files, right? That is a good practice, so that auto growth will not come in picture immediately.
Because I can
More,
see,
this is my system for demonstration purposes,
yeah,
not
I can
box.
understand.
Yeah.
In second file, I can see 254 MB size is there.
Maybe I demonstrated something, that's why I changed it, right? I may be
Okay.
talking about that you should have sufficient initial size assigned to your data file. So I might have changed it, right?
Okay. Okay, thank you.
Okay, let us come to the next topic. So is this a screen visible, or should I put it into slide mode? I think that it would be better if I put it into
Yeah,
slide
that
mode,
would be better. Yeah,
right?
that would be better.
Right. So you can see here on SQL Server configuration level settings, what are the settings we can optimize, right? I have included all those settings here, starting from affinity mask. This is, not well understood by all the administrators or developers, right? But this is a very important factor that affects your performance, affinity masking, right? How you are assigning processors to SQL Server. Say I have 16 processors, right, on my SQL Server. So should these 16 processors be, provisioned under a single Numa node, right? That we have to understand. The answer is no. Under each Numa node, you should not have more than 8 processors, right? That you have to understand. The Numa node that you have in a server, it depends upon the number of sockets that has been assigned to the server. So if there are 2 sockets assigned, right, and 16 processors have been assigned to those two sockets, you will see 2 Numa nodes are there, and under each Numa node there are 8 processors. So it's a good practice to keep only 8 processors under each Numa node. But sometimes what happens, provisioning people are not known to this. Even while you are provisioning the server, you are not mentioned. While you are uh, opening a change ticket for provisioning a server, you are not mentioning that under I need 16 processors for this server, and under each Numa node I want only 8 processors. You do not do that, right? So you should follow that practice. We will have a big discussion on this. This comes under affinity masking as well, right? And affinity masking also plays a very important role when you have multiple instances installed or hosted on a single VM, right? There also it plays a very important role. So affinity masking is one of the server level setting. Then memory configuration options, I think most of the people know about it, that you must specify a high memory and the low memory, right? So again, it's a big discussion also. It's a big topic of discussion also, right? So why you should define minimum memory and maximum memory? So for maximum memory, many of the people are clear that my SQL server should not consume all the memory of the server, so that operating system itself will not go into the pressure, right? That's why we specify high memory for high memory for SQL Server. But why you should specify minimum memory as well, right? So that we will discuss under this course, because there is a war always going between operating system and SQL Server for the consumption of memory, right? So you must specify minimum memory as well, so that SQL Server will not release, on the request of operating system, complete memory for the operating system as well, right? Then cost is for parallelism and max degree of parallelism. These two are the topics we will discuss tomorrow. That is related to troubleshooting high CPU utilization issue, right? Optimize for ad hoc workload is a server level parameter that help you in improving the performance for your ad hoc queries. Your ad hoc queries are those which are not a parameterized query, or which are not part of a stored procedure, right? Fill factor plays a very important role, right, in performance optimization, because it helps you in maintaining the fragmentation of indexes, right? Block process threshold is one of the server level configuration setting that you can specify in order to capture blocking that happens within SQL Server using extended event. We will discuss about this under the course, how you can capture blocking that happens within SQL Server using extended events, right? Database file layout is a very important feature, important configuration setting, right? That where your data file should host, on which drive, where your log file should host, where your backup file should host, that you have to you know, understand under this configuration setting, database file layout. Database compression is still, I see some places in picture, but it should not be. Nowadays, storage is very cheaper, and it should not be in practice. You should not compress your database, right? Rather, you should compress your backup so that it will save a space. But again, you know, database compression, you have to understand what is important for you, the CPU cost or the storage cost. Storage is far cheaper than CPU cost. Storage cost is far cheaper than CPU cost. So database compression and uncompression, both are CPU intensive operation. They consume CPU time, right? So you should not enable any database for database compression, right? But yes, of course, when you are taking backup to save the space, you should go with compressed backup. Database administration, this is unnecessary point is there. I think no need of that point. I will remove this. Then your statistics must be updated to have the right estimation for the operations to be performed by a particular operator. Your statistics must be updated, right? Then you must maintain a minimum amount of index fragmentation, right? Then you should cycle your, or yes, the exact term is cycle. You should cycle your SQL error log file so that your SP read error log statement will not take more time to read data from the error log of SQL Server. You should avoid database settings or functions, you can say, such as auto close and auto sync. You must avoid. Then you must consider to take your database backup on a different disk drive than the drive on which your data file and log files are hosted, right? You must consider to take your transaction log backup, right, frequently, and this frequency must be decided as per the data loss that your business can tolerate. These are the things you have to. Then backup distribution, again, the same thing is there, that your backup should be scheduled on a different disk drive, configured to happen on a different disk drive than the data file and log file. And you should go with backup compression. It will help you in saving the space. Going ahead, we are entering into query design now, right? So every query that you write must be written as a transaction, and its first statement must be set no count on. Because every time you execute a query, it returns you some result set. So that result set is given back to you. Both are known to each other, Chandra and Mahesh. Okay, so both are set no count on. So whenever you execute a statement, say select a statement, update a statement, or insert a statement, right? SQL Server returns one error one message that this many number of rows has been affected, right? So when set no count is on, it does not return that message. So don't think that it is returning that message only to a single user. It is returning that message to thousands of users. So it unnecessarily consumes your network bandwidth, right? In order to save your network bandwidth, your first statement in your query must be set no count on. You must explicitly define the owner of an object. Your object is a table or a view, right? So you must explicitly define the owner, that what is the owner of that object. So say, for example, your schema is the owner of that object, right? In under a schema, that object is there. So you must write the schema. Say, for example, I have a table under cells or the detail under cells schema. I have a table called cells order detail. So I must write, say, select star from cells dot cells order detail, right? If it is under DBO, I should write DBO dot sales order detail. Likewise, you must explicitly define the owner of an object. You must avoid non-chargeable such condition, right? So under performance killer, we will try to understand this. What is a chargeable condition, when your condition becomes non-chargeable, and how your non-chargeable conditions gives birth to either table scan or index scan, ultimately which degrades the performance of your query. You must avoid arithmetic operation on the where clause column. So when you write a query, for example, if I have written any query here, it's not written here. Let us write a query here. So I'm writing a query, for example, here. Let us select a user database, update, sales order detail, set unit price, say 2020.00, where sales order ID, a particular value, I don't know the value. So let me execute the select command here. Say this value here. What happened? What I was talking? Yes. Avoid arithmetic expression on the where clause column, right? What does it mean? This is your where clause, right? This where clause that you have written here is known with many names. Most of the time we say that it's a condition. In relational algebra, it is known as predicate. In T-SQL language, it is known as predicate, right? So this is your predicate, right? This is your predicate or condition. So you should not use any function, right, on the column of your condition. Likewise, I should not do any kind of conversion, right, on the left-hand side of this column. That is the best practice, because ultimately it results into a scanning, either table scan or index scan. So guys, there are three access methods using which SQL Server accesses the data from the table. And these access methods are provided by a storage engine of SQL Server. So these access methods are table scan, index scan, and index seek, right? So even though this is going to qualify for seek here, if I select the plan to go with query and include actual execution plan, if I execute it in the plan, you will see that it is going with seek. Oh, sorry, its execution plan. Updating has been done. Ultimately, it is going with seek. You see here, right? Index seek operator is using against a non-cluster index. If you hover over the mouse, you will see the name of that non-cluster index as well under the object section, right? That non-cluster index is IXL's ID hyphen underscore detail ID, right? But if I put some conversion function here, unnecessary, or if it is required also, if I'm putting it, this index seek will be converted into index scan. That you should not do, right? That is what the meaning of that statement is there. You should avoid optimizer hints, right? Many people specify optimizer hints such as while they are, you know, joining the tables, they are specifying to go with hash join or merge join, you know, or go with nested loop join that you should avoid. You should not unnecessarily use no lock hint or any kind of force seek hint, right? Because optimizer is smart enough to use its operator, right? With what operator it should go. What I mean by the operator, I can tell you with the simple command here. Uh, Say for example, I'm making it simple, not as update a statement. I'm just writing here, select a statement. So now see the plan here. I mean that these are my operators, right? RID lookup, it's a bad operator. It should not be here. Then I have index seek as a physical operator. Index seek is a logical operation and a physical operation as well. RID lookup is a physical operation and logical operation as well. But if you come to nested loop joins, right, you can see here physical operation is nested loop and logical operation is inner join, right? So many of the operators have different logical name, but they are represented with a different name as physical operator. So these are physical operators: RID lookups, index lookup, computer scalar, you know, after that nested loop here. These are your physical operators. So we will discuss about many physical operators under the performance tuning, right? When we will learn about query tuning, we will cover many of the, you see here one case of nested loop join. You may see merge join, you may see hash join. These are physical operators. I mean that physical operator. You should avoid optimizer hints. I will tell you about this in detail. You should not use nested views. You can use views, but you should avoid, you should avoid the use of nesting of views. That is what I mean by nested views. You should not do any uh, 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 you must ensure that there is no implicit data type conversion is happening, right? So how you can see that, I will show you today itself if time will allow. Let us go somewhat faster. We have to first cover the syllabus. You must minimize the logging overhead. How you can do that, right? I will show you through some examples, but not today. During the course, we will go that how we can avoid the logging overhead, that the transaction that is logged in the transaction log, how we can avoid that. Then how you can ensure that you are following the best practices for reusing or reuse of execution plan. The best practices: write your queries as parameterized queries, or make your queries the part of your stored procedure. These two are the best practices for reusing execution plans. Adopt best practices for database transactions. What are the best practices for that? We will discuss about that. Eliminate or reduce the overhead of database cursors. We should not unnecessarily use database cursors until and unless there is a requirement for doing automation using sys views or tables. On the database design, the main important part is you have to keep a balance you have to keep a balance while you are normalizing the database. It should not be under normalized, or it should not be over normalized. So your database must be in 3NF. In a nutshell, you can say. Now, we will have list emphasis on this part, apart from learning these things: entity integrity, domain integrity, and referential integrity, how you can implement these things in SQL Server, right? So for that, you have to understand what is domain integrity, what is referential integrity, what is entity integrity. And then you will have to implement it using different constraints that we have in SQL Server. So for example, there is a constant known as check. Check constraint is used to implement domain level integrity. Primary key and unique key are used to implement entity integrity, and a combination of primary key and foreign key is used to implement referential integrity. How these integrities benefit SQL Server to maintain data integrity and its accuracy, and also how these benefits optimizer in creating the plan that we will discuss here. And we will have more emphasis on adopting the index design best practices, right? So we will cover here. Under the database design, you should use database triggers minimally. Wherever it is strictly required, you should use it. You should not unnecessarily name your stored procedure starting with SP underscore, right? You should avoid naming your stored procedure starting with SP underscore. If anybody is following this practice, don't follow that, right? So we will not talk about database designing, right? It's the complete task of database designer or database architect who are playing with the data, who has a good knowledge of any domain, right? Then only he can design the database. Rather, we will talk about integrity, data integrity in terms of entity integrity, domain integrity, and referential integrity. And we will talk about index design best practices here. Then when you are tuning a query, your execution plan is the best tool to tune and optimize your queries, right? So for that, you have to understand what is an execution plan, what are the different operators that makes a plan, how a plan is created, right? How a plan, how a query is executed, and how it goes through different phases before an execution plan is created. So it starts when you submit a query for the execution. First, it is passed by the parser against the syntax of that query. When the syntax is correct, right, then there is a component in optimizer that is known as algebraizer. So parser generates a parse tree and it hands over to algebraizer. Algebraizer, first of all, does a process that is known as name resolution, right? And under name resolution, it checks for the binding of the objects that you have specified in the query. When that is done, then it creates a query tree. Then the query tree is handed over to the optimizer. Optimizer may create a single plan or multiple plans. I'm using the term that optimizer may create a single plan or multiple plans. Many of the people you may uh, uh, you may experience saying that optimizer always creates multiple plans. This is wrong. This is wrong. Optimizer will create multiple plans against your query only when it has the possibility to create multiple plans against multiple indexes. If multiple indexes are not there or they are not meeting the criteria of the query, optimizer will go with a single index and it will create a single plan, right? So optimizer may create one plan or multiple plans. If it creates multiple plans, then it decides the best plan, that is known as optimum plan. And optimizer, SQL Server optimizer, is a cost-based optimizer. So it chooses the best plan as the least cost plan, right? And then it handed over that least cost plan to the query executor for the execution. Query executor executes that plan and it hands over, then SQL Server returns the result set of that query or the result of that query to the client. That is the flow. We will discuss this in detail. So what are the different components of the execution plan? Basically, a execution plan consists of multiple operators, some arrows, and some lines, right? So arrows also have their meaning, lines thick line and thin lines also have their meaning. We will discuss about those all things. Easing of the execution plan, how execution plans are cleared from the plan cache, that we will talk about under this. How we can analyze the execution plan cache, we will talk about that. How execution plan is reused, that we will talk. What is a dark workload, we will talk about. How we can optimize SQL Server for a dark workload, that we will talk about. What is simple parameterization, so for that we will understand what is parameterization, then we will understand simple parameterization. After that we will understand forced parameterization. What are the benefits of a stored procedure, that we will discuss. When to use SP execute SQL statement in order to execute the dynamic SQL statements, we use this stored procedure. We will discuss about this. What is parameter sniffing, what is bad parameter sniffing, what is good parameter sniffing, we will discuss under this. What is query plan has and what is query has, and how they help you in troubleshooting, high memory, that we will discuss here. What are the execution plan cache recommendation, where that we will discuss. And what is the estimated plan and what is actual plan, that we will discuss, right? When to use, when you should see estimated execution plan, when you should see actual execution plan, how you can compare that, we will talk about that. And these two important commands are there: set statistics time on and set statistics IO on. These two provides you insight of your query execution with the statistics of IOs that were performed against the table those are involved in queries. So how many logical reads were performed against each of the table, how many physical reads were performed against each of the table, how many scans were performed against each of the table or index. This information is provided by set statistics IO. And set statistics time on provides you information that how much time your query took to parse, compile, and execute. And there is one time. It also provides you information about the code execution time, that is known as worker time, right? So we will talk about this also. So these two, set statistics time and set statistics IO, when we on it, these two statements are very useful when you are tuning the query, right? So throughout the first session, I think from today itself, you will see that I will use these two statements in order to demonstrate, the performance tuning. Then, in order to understand the role of index and statistics, right, uh, uh, in query optimization, we will start to discuss about understanding of index, how we can do index analysis, what are the index design best practices or recommendation, what is cluster index, what is non-cluster index, right? What is the difference between these two? What is column store index? When to use column store index, right? So you have been using column cluster index and non-cluster index. Column store also supports both indexes, cluster index and non-cluster index, but you have been using most of the times row stored indexes, right? When to use column stored index. How many of you know about aggregate operations in SQL Server? Anyone? Hello, am I audible?
Yes, Neeraj, you are very much audible. So
Okay.
I heard about this but never used. So
No, you have been using it. Aggregate operations. Some function is an aggregate operation, average, mean, max. These all are your aggregate operations, right? Column stored index is the best candidate to perform aggregate operations. It makes your query execution very faster against aggregate operations, right? That is why I asked. The reason behind is that it stores data in segments. It does not store data on data pages, index pages. It stores data on segments. So we will have detailed discussion on that. So these are the things I already have talked about. Then statistics I have talked about. So for statistics, I will try to cover it today. There are two kinds of statistics. One is statistics created against indexes that you create, and statistics created against columns that you do not create, right? So when optimizer creates statistics and how the statistics is used by optimizer, right? That we will discuss today. Lookup analysis. Lookup is one of the operator in SQL Server. It's a bad operator, right? Basically, it comes in two flavors: RID lookup, and one is known as lookup that is created against your cluster index, right? So that is a lookup. So RID lookup and lookup, you have two kinds of lookup. How you can? Sorry, yes, tell me.
Yeah, key lookup, another one.
Yeah, the lookup that is performed against cluster index is known as key lookup, and the lookup which is performed against a table is known as RID lookup, right? So how you can deal with lookups? Lookup is a bad operator. You should avoid to see it in the plan, right? And by introducing some covering indexes or a covering index, you can eliminate lookups from the plan, right? SQL Server performs any joins using these three physical join operators. I have shown you one case of nested loop join operator in one of the update query, perhaps you have seen, right? It performs every inner join or outer join that you perform using either using hash join, merge join, or nested loop join. So we will have a complete class on this. When SQL Server uses hash join, in what case, you will have to understand the concept of inner table, outer table, right? And the different conditions on which optimizer decides with what join should it go. Query recompilation we will talk about. It's a bad thing, and it's a good thing also. It should happen, and it should not happen frequently for any query. So that we will discuss. Then how you can improve your performance of your queries using memory optimized table. And when you use memory optimized table, you must use natively compiled stored procedure to get its maximum performance benefit. Even if you create a in-memory optimized table, that table will be in memory. You think that your data retrieval will be faster there, or your data write operation will be faster there because your table is in the memory. But if you do not perform those operations, your read operation or your write operation within a natively compiled store procedure, right, you will not get the optimum performance, the best performance from the in-memory optimized table. So guys, natively compiled stored procedure is nothing but a procedure which you have written for in-memory table, and that is compiled by Visual C++ compiler. That's why it is known as natively compiled stored procedure. Natively compiled stored procedures are not compiled by regular SQL Server compiler, right? Then the concurrency control, transaction concurrency control mechanism in SQL Server, you have to understand that is implemented using two approaches. The first is pessimistic approach of concurrency control, and the second is optimistic approach of concurrency control. Under pessimistic approach of concurrency control, you have 4 isolation levels: read uncommitted, read committed, followed by read repeatable read, and finally serializable. These 4 isolation levels you have, those fall under optimistic approach of concurrency control. And these 4 isolation level works with locks. So basically you have 3 locks. One is shared, another is update, and the third is exclusive lock. So isolation level along with locks implements pessimistic approach of concurrency controls for transactions in SQL Server. We will have detailed discussion on these kinds, this concept. But at the same time, there are two isolation levels, a snapshot and read committed snapshot isolation levels are there. Those implements the concept of this optimistic concurrency control mechanism, right? So they work on row versioning principle rather than completely relying on lockings. Although you use shared locks as well, but they reduce the use of locks. They work on the principle of row versioning, right? So we will have detailed discussion on this part. It's a very interesting and advanced topic, right? Under this, we will also talk about log granularity that starts from row level locking, uh, going ahead, range row level locking. Then you have page level locking. Then you have table level locking, schema level locking. Finally, you have database level locking. So under this log granularity, we will also cover lock escalation also, right? And when we are talking about transaction concurrency control, obviously blocking and deadlocking will come in picture. So we will have detailed discussion on blocking and deadlocking and how to capture blocking and deadlocking using extended events and profiler, right? How we can also automate SQL Server to detect and collect blocking information using extended events that I will tell you. How you can perform deadlock analysis using extended events and profiler that we will learn here. How you can introduce catch and throw, try and catch block in your code for capturing deadlock information that I will tell you. Then these are the tools that usually I discuss under performance tuning classes. So from the day one, that is, you can consider from today, I will talk about this query plan. So query plan I treat as a tool, right? While you are analyzing the query. SQL Profiler is another tool, should be avoided. It is now deprecated, you can say, starting from 2000 itself. Why I'm saying deprecated? That Microsoft, starting from 2008, has stopped to introduce new events to be captured under Profiler. Microsoft is encouraging administrators and developers to use extended events. Nowadays, extended events in SQL Server 2016 supports more than 6,000 events to be captured, but Profiler can only capture near about 1,600 events. Microsoft is encouraging the use of extended events because it's a lightweight tool, right? And hence it does not consume uh, much CPU, not more than 1 or 2%. But SQL Profiler is a CPU intensive tool. That's why you must avoid to use it. Another tool we have is Plan Guide, and this is a very useful tool when you have to when you don't have access on the code that is written in the store procedure to modify, right? You can use Plan Guide to specify some kind of hint to the query, so that that query will always execute with the Plan Guide that you specify for the best performance. Live Query is a tool introduced in SQL Server 2016 and available onwards version, right? So it gives you live picture of your query execution, that where it is taking time from which operator to which operator, how data is flowing, and where it is taking time from which operator to which operator. So you can focus on your query to troubleshoot on that point. Query Store is a wonderful tool, again introduced in SQL Server 2016, and it's a wonderful tool. It's a database level feature. I treat it as a tool, and it is also part of your Azure SQL database, right, of all flavors. Whether your Azure SQL database is in a standard tier or in business critical tier or in hyperscale tier, this is also available in SQL managed instance, right? So this is a very useful tool that gives you insight of the queries that in the past 7, 15 or 30 days, which query performance have been degraded, right? what are the different queries that you have with maximum variance time of execution? That if your one query executes in 3 minutes and the same query executes in 7 minutes or 5 minutes, right? So its time is varying. So it's also capturing the queries which executed with variance time, right? It gives you the list of queries with their plan uh, on the basis of that, on the basis of the CPU time, on the basis of the worker time, on the basis of the logical number of reads, on the basis of physical number of reads. So there are multiple metrics. You can choose any of the metric on what basis you want your query, right? Which have been executed in last 7 days, 15 days, or 30 days. Apart from that, Query Store also has a wonderful feature that it provides you information of the plan ID of each of the query. And it gives you the picture that with how many plans a query have been executed. If a query has been executed with different plans, then you can see that with which plan my query executed in list time. And then within the Query Store, you can force that plan for that query. Basically that is revealed under plan ID. You can force that plan ID. You can force that query to execute with a particular plan ID always, right? So Query Store is a wonderful tool. We will discuss about that. Then we will enter into the troubleshooting part of troubleshooting high CPU utilization issue, memory issue, and IO issue, right? So these all are based on a lot of concepts you have to understand, and I think that these each will take at least one class to complete. So tomorrow I will try to complete troubleshooting CPU issue, and under that I will start with SQL Server architecture. Especially I will focus on SQL OS, because your troubleshooting CPU issue is basically related to SQL OS. Under SQL OS, there is a component scheduler, which is responsible for schedule your threads. Threads are your part of queries for the execution. Then under SQL OS, workers are also there, right? So workers, how many workers you have, it depends upon the number of processors you have. So first you have to understand how many schedulers you have in SQL Server. What a scheduler is? Scheduler is responsible for scheduling CPU time, or allocating CPU time, that is known as quantum, to the threads for their execution. Threads are the representation of queries. A query can be a single threaded query or a multi-threaded query. It depends that how your plan has been generated. If a query plan is a serial plan, it will be represented as a single thread to the scheduler. If your query is if your query plan is a parallel plan, it will be represented as a multi-threaded query to the scheduler. So how many schedulers you have in SQL Server? The answer is simple. How many number of processors you have in your SQL Server? So I already have shown you that how many processors I have. I have 4 processors. If you want to see how many schedulers you have, go to sys dm underscore os underscore and schedulers. Select start from. So you will see 4 user schedulers are there. Scheduler ID 0, 1, 2, 3. They are binded with CPU ID 0, 1, 2, 3. And remaining schedulers that you see, they are background schedulers. They are responsible for managing background processes of schedulers of SQL Server. Here you have user schedulers. Those are visible and online. 4 schedulers are here. They are tied with CPU ID 0 to 3. One more scheduler is here that is visible on online. This is reserved for dedicated administration connection. Now the question is for workers. So your workers information is shown under OS sysinfo perhaps. So I have 4 processors. I should have 512 workers available under 4 schedulers. So if you go to right, scroll right, you see here max workers count 512. Scheduler count is 4. These are the user schedulers, and max worker count is 512. So more the number of processors you have. For if you have 8 processors, you should have 712 or 16 workers. If you have 16 processors, you will have more workers. Likewise, you can Google, you can see, right? So we will talk about these all things tomorrow. Scheduler follows some algorithm, right, to assign CPU time to the queries, to the threads, right? So there are 2 algorithms: preemptive scheduling algorithm and cooperative scheduling algorithm. SQL Server follows cooperative scheduling algorithm. So we will have detailed discussion on this tomorrow. Quantum is nothing but it's a 4 ms time, 4 millisecond time that is assigned by the scheduler to a worker thread for the execution of a thread. Then we will discuss about how threads are scheduled by the scheduler. We will discuss about scheduling algorithm, that is preemptive and cooperative, and what is the difference between these two. Since they are scheduling threads, so thread has a life cycle. What is the thread life cycle? That we will discuss. What is max stop? That we will talk about. Then we will talk about cost threshold or parallelism, right? How these two are interrelated, we will talk, and how these two play important role in troubleshooting high CPU utilization issue also. Then we will talk about the CPU weights, SOS scheduler yields, CX packet, and one is missing here, that is thread pool. And I will tell you how to analyze the statistics. Those will appear against these 3 weights: SOS scheduler yield, CX packet, and thread pool. Finally, what is signal wait time? What is wait time in MS? Those things we will discuss, right, in order to troubleshoot the CPU. This is the topic for tomorrow. And the last thing of the course that we will cover is troubleshooting high memory performance issue, troubleshooting or high memory utilization issue, troubleshooting high IO utilization issue, and troubleshooting temp DB contention issue or the space issue. There are 2 issues usually we face with temp DB. Those things we will cover. So this is all about the course that we are going to cover. I think that we are done with the course overview, right? I will be back in 2 minutes, and then we will start to learn about performance killers in SQL Server. It's okay. So it's not like that. I will wrap up the session at 9 p.m. I think that it will take next an hour, right? So be there. I will continue after 2 minutes. So I will be back in after 2 minutes. And if you have any question, think about that. You can put your questions. From there, we will start, and then we will enter into learning the performance killers that exist in SQL Server. Okay. So we have covered the syllabus. If you have any question from the syllabus or anything, feel free to ask. Then we will go to the next topic for discussion. Do you have any question?
So, do we have HNDR in this syllabus, or that is out of this scope?
No, this is for performance tuning. That is part of that is part of what I would say, DBA
Okay.
batch.
So, will this, be beneficial for DBAs or only for developers? What is the concept of this, designing this course?
This is for
So
both.
it is for everybody, DBAs
Yeah,
and
yeah.
okay.
This is for everybody. So, for example, one of my student here, he should be here. Vivekanand, you there? He is the part of DBA batch, right? But recently he was interviewed and many questions were asked from the performance tuning. Right, Vivekanand, you there?
Yes, yes, sir.
Yes. So many of the questions they asked from performance tuning. So the trend is changing, you know, and many of the DVAs have attended this course, right?
You have any batch for DBA, SQL DBA?
That is going on, right? And I am covering a lot of things there, starting from SQL Server administration to Azure SQL, then automation using PowerShell, performance tuning, right? Everything was there. So the duration is very long. The course is going from 3 months, right? So next batch for DBA will be formed, I think, in December, not in November.
Okay, and what would be the course fee for DBA?
For that, it was 18K,
Okay.
right? But from the next batch, I will exclude some of the topic from there, and I'm planning to keep it down to 10 to 12K.
Okay, okay. And it is from basic, I mean, from scratch to till advanced, right?
Yes, yes.
See, I am basically into sysadmin. I have no knowledge in DB. Can I enroll for that course?
But you will have to wait for December, or I have recordings. You can avail that recordings.
But is it feasible? I mean, that would be feasible for me because, as I told, I am from sysadmin background. I mean, networking and basically server administration
Yeah,
background.
see, the first thing is that you have to decide that in which direction you have to go, and it all depends upon your, curiosity, and after that, then your eagerness for seeking the knowledge. There are two things, right? As a teacher and as a senior person, my responsibility is to guide you properly, right? I cannot misguide you. So it all depends on your interest, your curiosity, in which direction you want to go, right? If you want to go for database administration, all right, so nothing is impossible to learn. You must have the eagerness to learn. You must have that curiosity. So first decide that in which direction you have to go, whether you have interest or not, right?
Right. Thank you.
Okay, sorry to interrupt you. I have not seen like disk label analysis whenever there is, data sudden growth in, disk data files and all. So I have not seen that like point. And
That is
will
that,
that performance monitor will be included in this? That is
uh,
there.
that comes under monitoring. It does not comes under performance tuning. Try to understand that,
Okay.
right? That comes under monitoring. But if you have some
Okay,
specific
fine.
topic, so if you have some specific topic, just what you can do, you can enroll in the course. You can drop me those questions. I will cover that also. So it is not like that I will cover only these things. Many of the people, like if Ravi is there in the course, so Ram Kumar is there. Whatever issues they are facing in their day-to-day environment, right? They are calling me on interval of 1 day, 2 day. One person is there from US, what's his name, Sakar, right? There are many people who have enrolled in the course, and whatever problem they are facing or what they want to know, they are keep talking to me, and as per my time, I give them time. So that is not a problem.
Okay. So what is the course duration and when it will happen? Weekend or weekdays?
It will happen on weekends, Saturday and Sunday. Course duration will be of 6 weekends. The timing will be 7 p.m. to 10 p.m. IST, right? So on every
Okay.
Saturday and Sunday, it will happen every Saturday and Sunday. The fee is 12K, in INR, and that you have to pay as a single installment. And only 10 people can enroll in the course, right? The batch will not more than after 10 students. So admission will be taken on the first serve, first come first serve basis. So it's not like that if 20, 30, 40 people are coming in a batch, I will entertain them. Maybe I will form another batch for them, right? But still I'm not able to form another batch because my SQL DBA batch is going on. So I already have 2 batches, right? So only 10 people I will entertain in the course. In the last batch also only 10 participants were there. So for every batch only 10 participants will be there. And the course we are starting, I think that I have mentioned in the mail here. What is that mail?
I think it is in Facebook, sir.
Oh, sorry. I am receiving a lot of comments. I received more than 300 mails from the comments, but I can see only 20 participants, 30 participants earlier, now 20, 21 participants. Why people are commenting then, right?
So probably might be, like even I am shift right now.
Hmm.
So the reason is like many people are working,
Okay.
shift as well. So that may be the reason.
Okay. Maybe one of the reason.
And even like, my shift, is on weekend. So like it keeps
Hmm.
rotating, and Saturday, Sunday, I'm in shift.
Thank you. Thank you. At least it gave
So
me,
that is one, challenge.
at least it gave me one reason to understand. Okay. Thank you very much.
Yeah, yeah. So do you know
Uh,
Bikal Pratap Singh?
yes. Yes,
Because
Vikal
I have
was.
seen like he is added in your mutual friend list.
Yes. Vikal was in HCL right now. Where he is?
So right now, maybe he was there in Rec Space. So like he was my colleague in Bipro earlier, and
Okay.
even I'm in HCL right now. So he just moved,
Okay.
from HCL to Rec
Yeah,
Space.
Vikal
I have
was
seen
there.
his profile added in your Facebook, so I
Right.
thought you know him.
Right. Vikal was in HCL, and before that, he was in which company? One of the American company he was
Yeah,
perhaps.
Wipro. Before HCL, he was in Wipro with me.
Okay. Okay.
Yes, Genpact. Genpact was the client.
Okay. That's good. Good. So you talked about this demonstration class. Today we are in demonstration class. Tomorrow is the demonstration class at same time. The timing is 7 to 9 p.m. for this demonstration class. Duration here I wrote here 3 weekends, 6 weekends, 3 hours on each Saturday and Sunday, but usually it go to 7 to 8 weekends, right? Because
Okay.
at least it goes to 8 weekends. So sorry, 7 weekends because see, I am starting this batch from this date. What is the date? So 6th or 7th of November, right? So complete November will be there. Then we will enter into December. So mid of the half December will be 6 weekends. Then I have 1 weekend free. So I usually assign them to that to my students. So that is not a problem. Then
Okay.
everything is clear now, right?
Yes, yes.
So let us just start then. Okay, so recording is going on. Yes. So as we talked that SQL Server performance tuning is broadly covered into 4 areas: SQL Server level tuning, database level tuning, query level tuning and database design level tuning. So try to understand these two terms. Database level tuning means database parameters level tuning, such as database initial size, its auto growth size, database file layout, right? These are the things that comes under database level tuning. And then you have database options, such as what will be the default setting for your auto close. It must be set to false, right? Then auto shrink must be set to false. Auto update must be set to true, right? Auto create an index or auto create statistics must be set to true. For legacy applications, legacy cardinality estimation must be set to true, right? So these are the different database level settings that comes under here, database level tuning. And database design level tuning, right? As we talked that we are not involved in database designing, so we cannot enter into database designing part, and we cannot analyze where database is in 2NF or really it is in 3NF. That we cannot decide. But yes, of course, even as an administrator, you cannot deal with database integrity, but as a developer you can dig down and into the integrity part of the database, that how it has been defined, designed, how the primary key has been designed for maintaining entity integrity for the database, how the primary key and foreign key has been implemented in database for maintaining referential integrity for the data, how the check integrity has been implemented in tables for maintaining the integrity of database on domain level, right? These are the different things that you can do. But as a database administrator, you have to also ensure that whether proper indexes have been implemented in database or not. So for that, uh, you can do the query analysis, right, against index analysis against the queries, or even you have DMVs to find missing indexes, right? You can do that. And you can also provide a report for unused indexes, why they are there. Unnecessarily, they are consuming CPU time for maintaining the overhead of the indexes, right? So let us start to understand what are the different performance killers we have in SQL Server. So under performance killers, these are your major performance killers. Let us start from missing indexes, right? Then we will enter into stale statistics. We will try to understand implicit conversion as well. If time will allow, we will cover fourth, fifth, sixth, seventh, these things. Or let us see what we can cover. So let us try to understand the case of missing indexes by capturing Tilif. Can you come out from the video mode? It will consume entire bandwidth. Dilif, can you hear me? Can you come out from video mode? Yes, thank you. Hello, am I audible to all?
Yes, sir.
Yes, you are audible.
What is happening here? Let us close this. So you see here, the first statement that I have included is set statistics IO on and set statistics time on. These two will provide me information about the IO statistics that will be performed against each of the table. Tables involved in this queries are sales order header, sales order detail, product, customer, and person. 5 tables are involved in this, right? So how many physical reads, how many logical reads will be performed, and how many scans, index scan or table scan will be performed against each table, that will be captured by this statement, set statistics IO on. Set statistics time on will give me the picture that how much time my query took to parse, compile, and execute, right? It will also give me the picture for the code execution time of the query, that actually, apart from parsing and compiling, how much time my query took for execution, that will be captured there also. So while tuning a query, you must include these two statements in order to gather the IO statistics against each of the table and time statistics against your query uh, parse time, compile time, and execution time, right? So let us see. Now, let me tell you the rule of thumb of indexes first before executing this query and capturing its plan. The rule of thumb for indexes is that the column which appears in your predicate in relational algebra, I'm repeating it again, the condition that you write with where clause is known as predicate, right? Do people experience some background noise from my side?
No, sir.
Okay, that's good. So the first level of index that you must always seek for while you are writing a query, the column which appears in your condition, that is in your predicate, must have at least a non-clustered index, right? If you don't have, certainly it will be a case of missing index. Second level, when you are coming to join operations in your query part, check that on what columns you are joining the tables, those columns have at least non-clustered indexes or not. For example, I am joining customer table and sales order header table on customer ID column. So I must have a non-clustered index or a clustered index created on the customer ID column of the customer table and customer ID column of the sales order header table. Likewise, I must have a non-clustered or clustered index created on the product ID column of the product table and product ID column of the sales order detail table, right? Same thing, I must have a non-cluster index or a cluster index created on sales order ID column of the sales order detail table and sales order ID column of the sales order header table. If you have indexes created on these all columns on which you are joining tables, right, you will have faster response from your query, right? The third thing is that whatever columns you are projecting, I am using the term projecting. So in this query, you are doing three things. In relational algebra term, you are doing three things. The first, that you are using putting a condition here, you are doing a selection operation here. In relational algebra, it's a selection operation, right? Means that you have many records in your result set, and out of that result set, you are filtering out, you are selecting the rows or the records which meet this condition. So this is selection. The table which you are joining are columns is your join operation. So this is your selection, this is your join operation, and finally whatever columns you are selecting for retrieval for the result set is your projection, right? So rule of thumb is that you should go with minimum number of columns for projection. You should not put select a star like that. If you are dealing with a single table, select a star from any table. Say that table is having 50 columns, so it will return you data of 50 columns, right? Now you should minimize your columns in the projection list, right? So three operations you are performing. One is selection, another is join, and here is projection, right? All are clear here?
Yes.
Yes.
Okay. Now, in order to tune this query, right, or find the missing indexes for that query, or see what is the problematic area in this query, right? What I will do, I will capture its query plan. I treat query plan as the best tool to tune queries. So I will go to query, and then there are two ways to capture the plan. The first is you can go with display estimated execution plan. Second way is you can capture the actual execution plan by selecting this option, include actual execution plan. So in which case, what you should do, what you should use. If you know that your query is taking a long time to execute, say your query is taking 20 minutes to execute, and you are given the task to tune that query, right? So you should not go in the initial phase for that query to capture its execution plan, because you will get that execution plan after 20 minutes. So you are just wasting your 20 minutes time, right? It's better to capture its estimated plan, right? So let us capture this query estimated plan first. If I come to the message, I don't have any IO statistics or time statistics captured here. So when you capture the estimated execution plan, the IO statistics and time statistics are not captured. Those are captured only when your query executes actually. Now come to the execution plan here. So under the execution plan, what I see, it's not suggesting me any missing index here, right? It's not suggesting me any missing index, but some problem is here that it is going with RID lookup. I don't want RID lookup to happen in my query. It means that I don't have a cluster index created on this table, perhaps. Sales order, which table it is looking for? Sales order, detail. Yes. So let us expand this database. Where is sales order detail? This one. I don't have any cluster index, right? So let us first create a cluster index, and during one of the demonstration, I created two missing indexes. One is also created on line total. That's why it is not showing. So let us delete that first. Let me delete the line total column. Sorry, index from here. Let us delete this missing index also from here. Now, what are the things I have? It's fine. Let us create a cluster index first on this table. So what are the columns we have in this table? Let's just try to find out that. Spelling is incorrect. These are the columns we have: sales order ID, sales order detail ID. I know that my sales order ID contains duplicate value, so that is not a right candidate. Let me show you. Sales order ID contains duplicate value, so that is not the right candidate for creating a cluster index. Sales order ID, it's containing duplicate values. Sales order detail ID, oh, I did one mistake there. Let me look into different one. For example, I have something under DBO schema also. DBO dot my sales order detail I should have. It got changed in this also. That's problematic. Anyway, let us create a cluster index here. Sales order ID. Sales order detail ID on my table name is this. And then we specify the column name, right? It will be a composite key. So sales order detail ID. The spelling is correct. Sales ORD or detail ID. Let us execute it. It will take some time and we'll execute. It's done. So my cluster index is created now. Let us see the plan now. And the RID lookup that was appearing will be banished in this case. And we will have only this time key lookup in this case. So even key lookup is also vanished, right? It's not appearing here. That's good. Now we see the problem. Cluster index we have created. We see the problem of missing index. So this is suggesting me to create a missing index, right? Why it is suggesting? Let us capture this here, right click and click on missing index details. So it's suggesting me to create a missing index on line total column, including the product ID. So let us forget about product ID. We will talk this later on. It's suggesting me to first create a missing index on line total column. Why? As a rule of thumb, I told you that my first rule of thumb is that I must have a non-cluster or cluster index created on the column which is appearing in my predicate part of the query, right? So it was not there. I deleted it deliberately. It was not there, right? So that's why it is suggesting, right? So let us go ahead and now the second thing. Now the index is missing. So see the impact here, how we can analyze the impact of this query, right? The two things we can do. One thing we can do here, we can go to message before creating that index. Let us go to message. Why it is not capturing this? Okay, we went with estimated plan. So let us go with the actual plan now to capture the IO statistics and time statistics for this query. So let us delete these statements or comment them out. Let us execute it now. Now come to the message. So here in message, what is the troubleshooting? What is the performance tuning arch? Here, on what you have to focus? You have to focus on the scan counts which have been performed against each of the table, right? So I can see that against product table, 0 scan count, against person table, 0 scan count, against customer, 0 scan count, against sales order header, 0 scan count. Against sales order header, scan count is 1. That is the first thing I note, that it includes 1 scan count. Second thing, check for the logical reads and physical reads. So guys, a scan count simply means a table or an index, right? Against sales order detail table, we have a cluster index. So that cluster index has been completely scanned using the index scan operator. That's why you see here 1 scan count. For these, there was no need of a scan count. It means that they went with seek, right? Next, there are two terms, logical reads and physical reads, right? So physical reads are those reads for which data pages have been read from the disk. Those pages were not available in the SQL buffer, right? Those pages have been read from the disk and then loaded into memory. That refers to physical reads. Logical reads are those reads for which reads have been performed in the SQL buffer itself. It means that those data pages were available in the SQL buffer itself, and there will no need to read those data from the disk and load into the memory. So less the physical reads you have, more performance you will have. It means that your page life cycle, PLE value is good, right? Now, next you have to focus on logical reads. Which one is having larger logical reads, largest or larger logical reads? So I can see that in this case, sales order detail table, against sales order detail table, the highest logical reads have been performed, that is 1259, right? And against sales order detail table, if I capture this plan again, if I come here, include the actual plan, and if I go to execution plan, I can see that against the sales order detail table, it is suggesting me to create a non-cluster index. Here is sales order detail table, right? So if I create this missing index here, right? While you are creating a missing index, it's better you write the first word as missing, underscore IDX, underscore, and on which column you are creating, specify that line total, right? Let us create it. So this index is now created. Let us not execute this command right now. Let us capture this output first. Okay. So I will discuss about this also. Let us capture this output first, or the complete output. Let us capture. So before creating index, I have captured the IO statistics and the time. So my query took total 230 ms time for compilation, plan generation, and execution. And it took my query execution time was there out of 230 milliseconds was only 141 milliseconds. This is the core execution time, or known as worker time, right? So this is the code execution time or worker time for the query. Got it? And this gives you the picture of your complete pass time, compile time, and execution time of the query. So I have the data of IO statistics and time statistics. Now I have created the missing index. Now I will execute this query and capture these statistics again, right? And then we'll compare that what is the difference we find. So come to the message now and capture it. So here we see that uh, two work files have been created, but they are negligible, right? Logical dates are 0 and 0. Work files are temporary files. Those are used to store temporary, sorting data, kind of intermediate results in the temp TV. That is fine here. No logical reads, etc. have been performed here. For here, product table, one scan count, one scan count have been increased here against product, person, and customer. What is the big achievement I can see here is that my logical reads against the sales order detail table have been reduced from 1256 or what it was to 3 only, right? And more important thing is that I see that my code execution time, that is the worker time of the query, is only 47 ms. So let us compare that time here. This time it's only 47 ms. Earlier, how much it was? It was 141 ms, right? So there is a difference of more than 100 ms in my query execution. Although the total pass time, compile time, and execution time is not much different, right? It's also 230 ms, and here it is more, 243 ms. Does it mean that this query is taking more time? The answer is no, it is not taking more time, right? Because the main time is here. We have to focus here. Next time if I execute this query again, right, you will see there will be a drastic reduction in the elapsed time. There should be. If you come here now, you see from 243, now it has reduced to 148 only. And this time my query got executed only in 16 ms, right? So this time, this is the time that you have to focus, 16 ms, right? You have to focus here. This is the usual practice that we follow. We notice the scans, we notice the number of logical reads, we notice the number of physical reads that are performed against each of the table, and finally we focus here on the code execution time of the query. So after creating the index, how much difference I find? Dilif, can you go on audio mode? It's disturbing, yeah. So what I was talking, yes. My query got executed in 16 ms, and earlier it was taking 141 ms. So that is the impact of creating index you can see here, right? So due to missing index, it was taking 141 ms for the execution. And when we created the missing index, it took only 16 ms, right? That is the point we have to note. So in this way, you can find missing index against a particular query, right? That execution plan is the best way to do that. Any question here? Okay, guys.
So,
So
sorry to interrupt you.
yeah, tell me.
How
Tell me.
you change that parameter, like execution and something like that? You are changing. So how you did it? Right click and then change.
Here you are saying this one.
Yes, yes, yes.
So simply
So
I have to capture the execution plan. So
okay,
to capture the execution plan without executing the query, actually we are capturing estimated execution plan, right? So for that you have to select the query. I selected the query. First you select the query, right? And then go to query and click on display estimated execution plan. Your execution plan will appear immediately, right?
okay.
This
I have to select and then right click and then query.
no,
Okay,
no, not right click. You have to click on query menu, and then you have to select display estimated execution plan.
okay.
So
Query
this
menu.
gives me the execution plan, estimated execution plan without executing the query. If
Okay,
I have to capture the execution plan after execution of the query, I will click here, include actual execution plan, right? And then I will execute the query. So that time it was unselected. Click on include actual execution plan and then execute it. So now you are getting the actual execution plan after the execution of the query, right?
okay, got it.
I will send this recording to all, but not the document. Document will be shared only to those, right, who will enroll in the course. Next, very important and very misunderstood thing is your statistics. So performance killers, second performance killer is your stale statistics or outdated statistics. But before you understand stale statistics or outdated statistics, let me explain what a statistics is, right? So answers from your side. What a statistics is. No answer. So guys, the first thing, statistics is a database level object. First thing, statistics are created against indexes that you create. For example, I created a cluster index. Let me show you here. If you remember, I created a cluster index for this table. You remember that? Let us refresh it. Let us check for indexes. There are many indexes, but I created this cluster index, if you remember, right? So let us copy it. I created this cluster index. When I created this cluster index, a statistics has been created automatically with this name. PK sales order ID, sales order detail ID. Let us see. Let us expand the statistics. I didn't create it manually, but it got created automatically. You see here. This got created automatically, isn't it? The last one, PK, this one I am talking. This is my index that I created, cluster index. Today I created, right? And this index got created. This was created due to this setting on the database level. That is auto create a statistic set to true. If you go to options, and this option must be set to true. By default, it is true, and it must be set to true. Auto create statistics set to true. Never set it to false. Otherwise, whenever you create an index, you will have to create that statistics manually. It's a poor practice. Don't do that. Always leave it enabled. Always set it to true. So that is statistics created. Now the question is, what a statistics is? So the first thing, a statistics is a database level object. The second question is what it contains. And the third question is what for why it is there, what purpose it serves to the SQL server. There are three parts, right? So a statistics is a database level object. Now come to the second part, what a statistics contains. So a statistics contains distribution range information of the data of the column on which you have created index. I created index on these two columns. This cluster index I created on two columns, sales order ID and sales order detail ID, right? So for which column its distribution range data it should contain or store. So if you create an index on two columns, statistics always stores your data for the first column on which you have created the index. So this is the first column, this is the second column. So my statistics will contain the information of this first column, right? Now, my sales order detail table contains more than 1 lakh rows, right? So I use the term that it stores distribution statistics for the data of a table. What does it mean? Let us try to understand that. Select a star from this table. This table contains more than 1 lakh rows. Let it come. So it contains 1,21,317 rows. You can see here, right? The question is, does my statistics contain information about this 1,21,307 rows? The answer is no. My statistics does not contain information about this number of rows. Rather, it contains the information of the sales order ID, which is stored in 1,21,317 rows, that from what range to what range, what data is stored, right? So let us see. Now statistics maintain a structure where it contains the data of distribution range for the index column. That structure is known as histogram. So this dbcc show statistics command accept two parameters. The first is table name and second is your statistics name, right? So it gives you information in three panes. The third pane, last pane, is known as histogram. Let us see it. This is a three pane structure you can see here. The first is general information, the name of statistics. Second, when it was updated. Third, how many rows it for how many rows it contains the information, how many rows were sampled for creating this statistics, how many steps it contains. It contains 153 steps. This is important to understand. So the complete 1,21,372 or something rows was there. Those rows data information in statistics is stored in 153 steps. Here are your steps. This is the third part that is known as histogram. So this contains 153 rows. You can see here, right? Exactly, it starts from 1 and finally you will see 153. So what it stores, it is, now you see here, it stores the information of your sales order ID, not information of your second column sales order detail ID, right? You see here, these are the information related to sales order ID. You see here sales order ID 43659, you go, it will go like that, 43361, like that it will go. So it does not contain information of your sales order detail ID. So statistics is always created on the first column of your index, right? If you have a specified only one index, then it will contain information of that index values. If you have a specified, you know, if you have created an index on more than one column as a composite key, say 2, 3, 4 columns, right? Then in that case, statistics will contain information of your first column. So here you see the information of sales order ID. Now here, the question is how it helps optimizer in creating the plan, right? So whenever optimizer creates a plan, it decides the number of estimated rows on which an operation has to be performed, whether it is a read or write operation by a particular operator, right? So let me show you here one example. For example, I am writing a simple query here. Select start from sales order detail where sales order ID equals to a particular value, right? Now, I'm not executing this command. How many rows it is going to return me, right? So for that, optimizer will do an estimation. How it will do the estimation? It will get that information from the histogram. So come to the value here, 43659. 43659. Range rows is 0. Let us talk about this equi rows right now. 12. We have put the condition sales order ID equals to 43659. Equivalent rows to 43659 is 12. That is the information that statistics have in its histogram, right? So optimizer will get the information that it will return me 12 rows. So let us not return this, execute this query right now. Let us see its estimated plan, right? So display estimated execution plan. And, you know, there are 3 access methods using which SQL Server reads the data from your table or index. The first is table scan, second is index scan, and the third is index C. So the access method that optimizer had decided to read the data is here your cluster index seek. Here is your cluster index seek. Hi, Brooke. You joined too late today. Can you hear me?
Yes, we can hear you.
Oh, I can see Brooke had joined. I said hi to her. Hi, Brooke.
Yeah. Hi, how are you doing?
Yeah, I'm doing good.
Sorry, my internet was interrupted for 5 minutes. That's why.
Oh, sorry. No
Okay.
problem. No problem. So I will share this recording with you. Okay.
Yeah, I know. I started from I already, was participating starting from the first part. So
Okay, okay. So you are from USA, right?
yeah,
Okay, that's good. Okay, okay. Let's just go ahead. So what I was saying, that optimizer decided to go with cluster index seek here. So this is the exit method that is provided by a storage engine. And this cluster index seek is used to retrieve the data from the table. Now, optimizer has done some estimation that how much record it needs to read from the index, right? So if you hover over the mouse on this operator and you see there in the first section from bottom to first, second, third, fourth line, estimated number of rows to be read, you see there 12, right? So from where it got that information? It got this information from the statistics. So in this way, statistics serves optimizer, right? Statistics serves optimizer to determine the estimated number of rows to be read in order to perform a particular operation, right? Guys, some background noise is there. Can you all go on mute? So all are clear here?
Yes.
Now, if I execute this statement and I capture its actual plan, right, you will see it will exactly return me 12 rows. And in the execution plan as well, right, it is returning me 12 rows. And in the execution plan as well, the same execution plan has been used. You see here, now two things you can see: estimated number of rows to be read and actual number of rows that has been read. So estimated number of rows to be read from the bottom, it's in the first section from the bottom, first, second, third, fourth, fifth line or sixth line is there, right? Estimated number of rows to be read is 12. And from the top, actual number of read, first, second, third, fourth, fifth, sixth, right? Actual number of rows read, that is the fifth line, perhaps, that is 12. Actual number of rows 12, number of rows read 12, right? So this is very important to understand. If you see the estimated number of rows to be read and actual number of rows that has been read are almost equivalent, right? In that case, you can say up to somewhat, not 100%, that your statistics is not stale or not outdated. But if these two have big differences, right, in the count, then it says that there is your statistics is outdated, or your statistics is stale, you know. So anyway, there are different ways to check for stale statistics. The first way to check here using this command, dbcc statistics, the first parameter is your table name. Since sales order detail table is part of sales schema, so I have specified this within bracket. And then second is your statistics name, right? So it gives me this information here. And when my statistics was lastly updated, I can see my statistics was lastly updated on 31st October here, right? Because I created the index today, right, at 9:22 p.m. And when I created the index, the statistics was created. That's why you see the date here. So it gives you that the date when your statistics was last updated. So if you execute the command sp update stats, right, statistics, then your statistics for all indexes, for all tables, for all databases, not all databases, for all tables will be created, right? Let us explore something more. Now we write some different query here. So we are writing a different query. I'm just changing this condition here, where sales order ID, and I'm writing a query here between this value and this value, right? So from where again, optimizer will get this information. I will calculate it later on. Let us see how many rows it is telling me, or let it calculate first. 43659 and 43692. In between these two cells order ID, how many rows this query will return, right? So again, come to histogram. We are contacting the histogram. Optimizer will also contact histogram for this estimation, right? Let us do this estimation. So equivalent to 43659, we have 12 rows, right? Equivalent to 43692, we have 28 rows. So how many rows we have? 12 and 28. It means that we have 40 rows equivalent to these two values. Now range rows. Range rows means that between this and this, how many rows are there? So we have 282 rows. So between this and this, we have 282 rows. Equivalent to this, we have 12 rows. Equivalent to this, we have 28 rows. So 12 plus 28, 40, 282 and 40. It's 322. Am I right? So optimizer will return me, this query will return me 322 rows, if I am correct with my calculation. So let us not execute this query now. Let us see the estimated plan. How much estimation of number of rows to be read has been done by the optimizer. Let us see it. Come to the seek operator here. See here, estimated number of rows to be read in the first section from the bottom, fourth line, 322. Estimated number of rows to be read, 322. Isn't it? Yes or no?
Yeah.
Yes, yes.
Right? So if I execute it exactly, I will get 322 rows. So let us include the actual plan. Let us execute it and see it has returned me 322 rows here, right? 322 rows. If I come to plan was not captured. So let us capture the plan, execute it. Come to the plan now here, come to the seek, right? Operator. So estimated of number of rows to be read 322, right? And from the top, you can see the fifth, sixth line, number of rows read 320, actual number of rows 322, 322, 322. That's fine. It means that my statistics is updated. If my statistics is not updated, the actual number of rows to be read, estimated number of rows to be read and actual number of rows that have been read, you will see the difference. So I think that you should have more insight of the statistics now. Am I correct?
Yes.
So in this way, statistics helps optimizer to perform estimation of number of rows to read to perform a particular operation, right? And it's not like that. It happens only for reading, for update also, for delete also. Always estimation has to be done, right? So that is all about statistics, right? And I think that I already have crossed the line. The time here, it's 9:56. We have started from 7:05. So we are unable to cover all the, topics here. Under performance killer, we were able to cover only these two topics, missing indexes and statistics. Let us try to cover the small thing, implicit conversion, quickly. So under statistics, there are a lot of things that we will discuss during the course. How to, what are the different settings on database level that must be on? What are their meaning, right? For statistics, what is column level statistics? We have not yet covered. Uh, let us try to cover one topic quickly here. So here, most of the developers unknowingly using a very bad practice, right? They are putting n before any string, writing any constant value, right? They are putting in. So it's a simple query, joining two tables here, right? Customer and person. And here we are comparing the account number column value with this literal. In relational algebra or in SQL language, this is known as literal, right? So many people say constant value, many people say a string, but it's a string literal, right? So we are comparing this with a literal. You will see that here is the case of implicit conversion is happening. What is that implicit conversion? My account number column is of, my account number column of the customer table. Let me check. It should be of varchar type, right? And when you put a n before a literal, my account number column should be varchar type. And before any literal, if you put a n, it becomes a n varchar, literal or a string, n varchar or a string. A varchar type of column stores each character in a single byte, and a nvar type of column stores its data for each character as 2 bytes, right? So for example, 1 2 3 4 5 6 7 8 9 or 10, how many are there? So if there are 9 characters, right, then they will be represented as 18 bytes in nvarchar. But if I remove this n here, right, now it becomes varchar. So it will be presented as 9 characters only, 9 bytes only, right? So let us put it in here again. SP help and sales customer. So I can see account number column. Account number column is of varchar type, you see here, right? It's not n varchar. What is the problem here in this query? We are comparing the values which are stored in account number column, which values are stored under varchar column. So all data are type of varchar. We are comparing varchar with n varchar of a string. So every value that is stored under the account number column in customer table will have to be converted into in varchar first, and then this comparison is successful. This conversion for every every column data for each of the row from varchar to n varchar ultimately gives birth to table scan or index scan. Let us see the plan now. So account number column is part of customer table. Let us see customer table here. And this is person table. Two tables are coming in picture here. So this is another reason, but a scan is being happen, right, against a non-cluster index. Index scan is happening due to this conversion. And how you can confirm that? So if you go to the leftmost part of your plan, you will see a yellow triangle. This is a warning sign, right? And here you will see some message related to implicit conversion that is happening here. It's bad thing because it is stopping optimizer to go with index seek. Rather, it is going with index scan due to this implicit conversion. We are not doing this conversion. If we do a conversion using convert function, right? Then that is known as explicit conversion. But here we are not doing the conversion, but due to the poor practice, right, this conversion is happening automatically. This is known as implicit conversion. You can see in the warning, type conversion is expression, right? Convert implicit. Nvar NC, that is the width, then account number. For account number column, it is happening with the value that we have specified, the literal that we have specified, may affect seek plan in the query choice, right? This conversion is restricting the optimizer to go with seek. Rather, optimizer is going with a scan against the non-clustered index for the customer table, right? So that is the problem there. Now, I'm doing nothing. I don't have to convert, I don't have to compare this literal as a in-CAD literal to the account number column values. This is a varchar literal now. Account number column type is varchar. So all data for all rows stored in account number column is a varchar type data. We are comparing it with varchar literal. There is no need of implicit conversion, right? So this time you will see there is a change in the plan also. This index scan should be converted into index seek, and consequently, this warning sign will be vanished. Let us execute it. Come to the execution plan. You see here that a scan is now, replaced with seek. No index scan at all, and that warning sign is gone, right? So this is implicit conversion, and this is a major killer here, because wherever you see a scan in the picture, whether it is table scan or index scan, it's not good. You should avoid that, right, guys? So I'm done for today, and I told you everything about the course duration, course fee, course timing. If you have any question, feel free to ask. And those who are interested for the syllabus, right? Leave it. I will send to all the syllabus. So tomorrow we will have demonstration or troubleshooting high ship utilization, right? If you have any curiosity, any question, feel free to ask. Otherwise, I'm fine to wrap up the session. So all are clear with everything, with the schedule, with the course commencement date, with the fee.
Yes, Niraj.
Okay. Okay, then. Thank you for your time today. And I will see you all. Hope you will join tomorrow at the same time at 7 p.m. Let us see. We will cover entire concept behind troubleshooting high CPU utilization issue. Okay.
Okay. Thank you, sir.
Thank
Thank
you.
Thank
Thank
you.
you. Bye.